It's a new thing, all right? I'm actually going to record it as well.
So this,
Yep.
this isn't going to be in the test?
Not in the test, but in the exam. I have to teach you because you need to know this in the exam. All right? So now we are looking at polynomials of the n degree. All right? So by the end of the lesson, you should be able to define a polynomial. You should know how to state the degree and leading coefficient of the polynomial. That should be a revision from last year. All right? Express a simple polynomial of low degree as a product of its linear functions. There should be an S there. All right? So what I mean is you must be able to fully factorize it. Use the null factor law to solve for the roots of the polynomials, and then use the fundamental theorem of algebra to state the maximum number of possible roots. That is a big sentence, but in fact, you'll find that you will laugh after you see what I do. All right? It's not that bad, the last one. So we have done linear function. What we have known so far, we know the linear function, which is y equals mx plus c. Right? We also know quadratic function, y equals to ax squared plus bx plus c, and then finally the cubic function. Hello?
I've got a new poster I've got to stick up here for everybody to read when they come in or when they go out. It's all about a uniform, from what I can see. Most people, all people.
Everyone here is pretty good. Yeah. I've no complaint about this class. I don't complain about this class about uniform. I complain about phone use.
About what?
Phone use.
Oh. But they're not supposed to be used them anymore.
Yeah, but still.
You have the right to take it off them. It's called confiscation.
I'll try, but I don't do that. Thank you. And then cubic is y equals to ax cubed plus bx plus c. All right? So now, what we have done is linear, quadratic, and cubic. Next bit, we are going to look at more than cubic. All right? So let's first start off with defining polynomial function. Let's have a look at all this. You've got a few functions there. Quite a few functions. All right? Notice that with these functions, the x all have power. All right? And this basically, if you can recall, is actually 3x to the power of 0. Because x to the power of 0 is 1. Okay? So now, let's have a quick look. What I've done is circle all the indices. All right? So for a polynomial function, you must have non-negative integer numbers. That is the most important. So anything to do with polynomial function is non-negative integer number. So this is how you could determine whether it is a polynomial or not. So if you have something like y equals to 3, x to the power of half. All right? That is actually not a polynomial. This is the lesson we're going to look at on Wednesday. Now, the reason why I have circled here the x is because that is x to the power of 1. All right? Just remember that that's x to the power of 1. All right? Next, go to the next bit. So here, the definition of a polynomial function. All right? It must have the following terms. Fx equals to, don't worry about writing it down, you will get it from the slide. You need to know n is the degree of the polynomial. N is always the highest degree. So go and highlight this word highest. Sometimes you will have all sorts of polynomials where you may have something like y equals to x squared plus 3x cubed plus 4x to the power of 5. All right? And here, to the power of 5 is actually the highest degree. So the degree of the polynomial is 5 for that example. The leading term. What you need to do is always organize in such a way that the highest degree is right in front. That will be your leading term. And then the leading coefficient is just whatever coefficient is out of the highest degree. Okay? And then finally, A0 is the constant term. Now, I did not follow the convention in your book. I prefer this convention. Your book Sadler used a slightly different thing, but they are the same. I prefer this convention because it's very clear that the first term, A0, with x to the power of n, it's the leading coefficient. It's a lot easier to understand, in my opinion. So I use this convention. All right? So now, let's have a look at this example. State the degree, leading coefficient, and the constant term of the following polynomials. First one, degree. This is how you write it. All right? Degree, deg of f is actually 6. All right? Degree of f is 6. And then the leading coefficient is 4. And then the constant term is actually plus 12. All right? Now, try the next one, please. And constant term. All right. Now, if you look at this gx, what is it telling you? All these are not in order. Yeah? So you do actually, my personal preference, I always rewrite it the correct order. Minus 2x to the power of 4 plus x cubed plus 2x squared minus x. All right? I prefer that so that I can see straight away the degree of gx is 4. Leading coefficient is minus 2. And what is the constant term? Sorry? 0. Because this is actually plus 0. Remember that. So the constant term is 0 in this case. All right? Plus 0. Anything to do with x is not constant because you can change. All right? You need to remember that. That should be the bracket. I forgot the bracket. All right? Just refer to, go back here. Bracket of f, degree of f, and degree of g. I just use it as a subscript, but it should be something like deg, f. All right? Now, if you are asked to fully factorize the following polynomial, how would you do it? Tell me. 2 examples here. You are asked to fully factorize it. First, when I say fully factorize, what does it mean? Come on. Yes? You do division, yes. What else? You can take out the highest common factor. What else? Yep. Sorry? No. Doesn't matter. What it? Sorry?
Fully expanded.
Fully. I think you mean fully put it into the brackets form. Sorry, it's not expanded. So I know what you mean. All right, it's not expanded. What else can you think of? Now, can you all remember something like oh, by the way, I missed something. Go back. Oh, actually, go back here. Notes, there should be a bracket.
Wait, sir, where
All right. Miss my own notes. Now here, fully factorize. Okay, very good. So first thing, you look at part A. You realize that you've got a highest common factor, we should can take it out. What is the highest common factor in this case? 2x. So you now know that gx, x is actually 2x. Take out the 2x, and it's x cubed plus 4x squared minus, actually 2x squared, minus 13x plus 10. All right? Now here, the way of doing it is to find, I'm going to write it out properly, 2, all right, is to find something which will give me gx as 0. Remember your remainder theorem, all right? If gx is 0, what happened? The x is a factor, all right? So I know that here, 1 is actually a factor. So let me substitute 1 in. It's therefore 2 times 1, 1 plus 2 minus 13 plus 10. All right, because it's 1, so therefore that equals to 0. So therefore we know that x minus 1 is a factor. All right? So once you know x minus 1 is a factor, what you can do is use your polynomial division or use your syntactic division. Yep.
Why is it minus 1?
Because if you go back, remembering your now factor law. All right. Oh, actually, I'll use 2 so that I don't confuse the issue. So here, x minus 1 could be equal to 0, or x plus 2 could be equal to 0. Therefore, x equals to 1 or x equals to minus 2. That's the reason why. These are the factors because of the now factor law. I know it's not intuitive, but yeah, that's what you need to know. So x minus 1 is now a factor. All right. What I can do is, you know that one of the factors is already 2x. So here, I can factorize this bit by doing a polynomial division or by doing a syntactic division by using x minus 1. X minus 1 is one of the factors for this. All right, got it? All right, I'm explaining it slowly so that you remember, since I didn't see you when I did the syntactic division. So I'm going to do syntactic division. I prefer that because it's so much faster than doing polynomial division. All right, with the syntactic division, what you do is you take the coefficient of this in here. So the coefficient is 1x cubed plus 2x squared minus 13x plus 10. All right? Then, because this is a factor, x minus 1 is a factor, what do? Where do you put the x minus 1? It's on the left of the equation. Hang on. So because x minus 1 is a factor, therefore you use 1 because g1 gives you a remainder of 0. So you put 1 in. Then the process, bring 1 down. All right? I'm using multiple colors so that you can see what I'm doing. Then 1 times 1 and bring it up to here, which gives me 1. And then I add them together. 2 plus 1, that will give me 3. All right? Repeat the same process. 1 times 3 will give me 3. Minus 13 plus 3 will give me 10. Minus 10. So 1 times minus 10 will give me minus 10. 10 plus minus 10 is 0. So therefore, here is x squared, x, and the constant. Got it? So the thing is, this is really useful, especially next year when you come to do a bit more on transformation. You get it very quickly rather than doing the long division.
Wait, when you say minus 10 is a constant, what's 3?
Sorry? 3 is x. So here, you started off with x squared, x cubed, x squared, x, and constant. Once you divide it by one of them, x, here will become x squared, x, and constant. All right? I will write that down. So here, just to explain it a bit better, This is x cubed, x squared, x and constant. So when you divide by 1, this is x squared, x, and then that's a constant. All right? Does it make it clearer? So therefore, you now know gx, x is 2x, x minus 1, and x squared plus 3x minus 10. And then can you factorize the last bit? Yeah? You can factorize the last bit, can't you? So equals to 2x, x minus 1, this 10, x minus x plus 5x minus 2. All right? So here what I've done is fully factorize the polynomial of gx into this form. All right? These are all linear. So you call this a linear factorization. You've factorized everything to linear. Later, I'm going to show you an example that you can't fully factorize everything into linear. All right? You may have something that you cannot factorize. All right? Now, next one, have a look at that. Can you see how you could factorize it? I want you to think about it as a little bit of a cheating way of factorizing this. I'm not saying anything first. I'm going to give you a couple of, maybe a minute to think about it. Talk to your friends. Now, I'm going to suggest something. If you look at this, all right, there is no x cubed, there's no x there. All right? If I let k equals to x squared, all right, this will become minus k to the power of 2, correct? X squared plus 5k minus 4. Got it? Make it a little bit easier. Think about it. Can you factorize this straight away? Yes, you can factorize this straight away. I will take the minus first out. K squared minus 5k plus 4. All right? So maths, in this case, you're looking at patterns. You're looking at how you could simplify this by substituting something in. So from here, you know that this is minus k, which is 1 and 4, and is minus and minus. All right. Now, this is not the end yet. All right? Yes? You can if you want to, but I'd rather not do that because it will complicate the issue. All right, I'd rather not do that. I prefer you not to complicate the issue, that's all. You will be dealing with negative numbers quite a bit. Yes?
Say you don't realize that, could you just solve it like?
Yes, you can. I'm going to show you this sort of method so that you can see it. I want you to learn that because that saves a lot of time. You can see that if you go through and do that, you're not saving as much time as that. Got it? So from here, you got to substitute x squared in. So it's minus x squared minus 1, x squared minus 4. And you know these are difference of perfect square, or difference of 2 square is minus x plus 1, x minus 1, x plus 2, x minus 2. All right? Makes life a little bit easier. I'll give you a couple of seconds to digest that. From here. Fully factorize. And, all right, next one. Hence, state the roots of this polynomial. All right? So we know that, all right, so if we ask to state the roots of the polynomial, all right, let me write it down. Write down the factorized form. So gx, x is now 2x, x minus 1, x minus 2, x plus 5. So again, expanding your knowledge of the null factor law. Any of these, 2x can be 0. This one, x minus 1 can be 0. X minus 2 can be 0. X plus 5 can be 0. The word state is important. So you're actually just stating it. So therefore, the roots of the polynomial is 0, 0, minus x plus 1, 0, plus 2, 0, and minus 5, 0. All right? I'm just writing the plus and minus to show you. All right? And then for the next one, fx, which is equals to minus x minus 2, x plus 2, x minus 1, x plus 1. The roots are 2, 0, minus 2, 0, 1, 0, and minus 1, 0. That's all. All right? Yes?
How did you get that first line of equations?
From the previous one. Therefore, the word hence is important. Hence state. All right? We will, okay, in terms of exam or test, you will always have something like this, hence doing that. You won't be asked to do something which is really more than you need to do. All right? Unless it's a separate question. Got it? Yeah. Next. So here, now, let's have a look at quadratic and cubic function. All right? So you know when there's quadratic function, the degree is 2. You can see that the number of roots is there and that. All right? Whereas cubic function, there's always at least one root. Cubic function, always at least one root. All right, therefore, if you look at this, so you've got quadratic function and cubic function. So the fundamental theorem of algebra actually states that the maximum number of roots for a polynomial of n degree is n. That's all. It's a big word, big sentence, but just remember, the maximum number is n. So here, for example, 2, you've got 0, 1, or 2. Cubic function, you've got 1, 2, or 3. So I have actually summarized it. If n is odd, there will exist at least one real root. If n is even, there may be no real roots. Yep?
So if the index is negative, it's not a problem.
No, negative is not a problem. So negative x squared, negative x squared, or negative x to the power of 4, negative x to the power of 5, that's no problem. It's still 5 is the degree, and then the maximum number of roots, it's 5. So it's something like, if you draw cubic, you know that positive cubic is always like this, and negative cubic is like this. All right? That's all. So it's a different shape. That's it. And then for quadratic, it's something like this or this. That's it. Okay? So, I think that's one last, yeah. All right. So now, let's have a look at this example here. Given that fx equals x cubed plus 2x5 to the power of 5 plus 4x to the power of 4 plus 8x cubed. Without factorizing, state the number of roots. All right? If you are stating the number of roots, what is the degree of this? So maximum you could have 6 roots. So 6 roots. All right? So, or actually you should, now, I would prefer you to do it this way, looking at my notes. So degree of f equals to 6. Therefore, at most, or maximum, 6 roots. All right? Give a justification, the degree is 6, therefore at most 6 roots. That will give you the full marks. All right? Sometimes you may have 2 marks, you may have 1 mark. So now, you are asked to fully factorize fx given that x plus 2 is a factor. All right, now we can actually start off factorizing by taking out the highest common factor, correct? Yes? Can you wait just 2 minutes? Just 2 minutes. I'll quickly finish this first. So very quickly, you can see that I can take x cubed out. X cubed, oops, what have I done here? So it's x cubed plus 2x squared plus 4x plus 8. All right? So taking x cubed out. and you know that x plus 2 is actually a factor. So therefore, writing 1x cubed, 2x squared, 4x, and 8, and minus 2. All right, bring 1 down. Minus 2 times 1 is minus 2. So 2, and 2 plus minus 2 is 0. Minus 2 times 0 is 0. 4 plus 0 is 4. Minus 2 times 4 is minus 8. 8 minus 8 is 0. So therefore, we know fx is x cubed, x plus 2, and x squared plus 4, because 0x. Now, this is a point. Can you factorize this further? Yes? X squared plus 4, you can. If you just look at it itself, x squared plus 4 is, if x squared plus 4 equals to 0, x squared equals to minus 4. That's it. So this is a point, fully factorized. Not everything is linear. The only thing is linear. This is x cubed, this is x squared. So here you can see that there are only 3 roots. X cubed, this is a triple root, because it's x cubed is a 3, it's a triple root. X, then that's 1, and then x squared plus 4, there's no root. All right? So that's, 2 roots only, not 3 roots. Okay? That's all I want to show you today. That's it. And you've got the exercises sorted out on Google Classroom. Please do that. Yes?
With that, do you have to take x cubed out to do that?
Which one? With what?
That. You took x cubed out.
Yep, I took x cubed out. So I know, so I know x plus 2 is a factor.
Yeah, no, I know why, but could you like factorize it before taking x cubed out?
I-
Does it have to be a constant?
Sorry, I didn't quite get your question.
Why, do you have to take the x cubed out to factorize it?
Okay, I took the x cubed up to factorize it is because this is the sequence of factorizing we do. We always start off with taking the highest common factor out. All right, and then we do the rest. Yep.
Why is it x squared plus 4 not x plus 4?
Because this is x cubed, x squared, x. All right. Once x cubed is divided by an x, you've got an x squared. So therefore, there's x squared plus 4. Got it?
I'm sorry. With that and the
Should actually write down the root. All right. So the root in this case is x cubed could be 0. X is 0. X plus 2 equals to 0. X equals to minus 2. X plus 4 equals to 0. X squared equals to minus 4. So this is no roots. So the roots are 0, 0, and minus 2, 0. That's all. All right?